is it puts together both problems, right? Like Katie recognized here, this problem is on the top and this problem is on the bottom, right? So you can't, can I solve the bottom one right away first? No, because I have two variables here. But can I do this one? Yeah, because 1, 2, 3 of them are numbers, and I'm just missing the fourth one. So give me the proportion, Chris.
I got 30 over t equals 25 over 15.
Good. 30 over t equals 25 over 15. Again, that will work, but remember the proportion is, or the theorem says that the sides are in the same proportion as the base. So, all right, so you get 25t equals 450. So t, let's see, it goes into 4, 16, 17, 18. So t is 18. Okay, so if t is 18, Maria, how would you set up that proportion for the second part? Right, 18 over 15 equals 12 over m. Good. So you get 18m equals 150 times 200, 1 maybe. So m is 10. Okay? Does that make sense? Do both of them? All right. And then for tomorrow's quiz is there are two really famous ways that you can solve indirect measurement problems. The first way is the shadow way, like if there's a giant pole and there's its shadow, and here's a person and there's their shadow, so you make two similar triangles. So the relationship, the ratio of x to y is the same as the ratio of a to b, right? We've done that a bunch of times. The other way that's kind of famous, this is the way like the ancient Greeks had to do it because they didn't know that the earth rotated around the sun, so they didn't know about the whole shadow thing. They didn't know, you know, they had all these myths about shadows that had nothing to do with the sun shining and causing them. So what they did was they put like a shiny piece of metal on the ground, and if they wanted to find the height of that pole, what they did is they put the shiny reflective surface on the ground, and then they backed up till they could see the top of the pole from the mirror. Okay, and that made, I didn't do a very good job here, but that made two similar triangles. Okay, so the same thing goes for this. X is in relationship to y is the same as A's relationship to B. I'm sorry? Well, Copernicus, thank you. I wanted to start with a P. Copernicus found out the Earth revolved around the sun, so he got it all started, I guess. I don't know specifically who came up with that, but okay. So there's just two. Those are the two ways that you most often see those right triangle problems. Okay. All right. So let's get our notes. Today we're going to talk about similar right triangles. So if you want to title your notes, it would be similar right triangles. All right, so I don't know if I'd bother copying all this down, but let me give you the paraphrase version. The right triangle similarity theorem says that if you draw an altitude to the hypotenuse of a right triangle, remember an altitude is the line from a vertex perpendicular to the side. It's like a height, another word for height. So if you draw an altitude to the hypotenuse, you create three similar right triangles. The little, I call them baby bear, mama bear, and daddy bear because there's a little one here, there's a medium one here, and then there's the big one. That's the original big triangle. Okay, so it's three similar right triangles. So today tomorrow we're going to learn how to find missing sides using these right triangles, but today we're just going to learn how to write similarity statements and how to calculate geometric mean, and then we'll put those two things together tomorrow and learn how to calculate sides. All right? What I did here was to get the problem with coming up with similarity statements is, like, for instance, look at the baby triangle. The long leg of the baby triangle is the same as the short leg of the medium triangle. And the hypotenuse of the medium triangle is the same as the long leg of the big triangle. So it kind of gets confusing because there's so many double duty parts. So what I'd like to do is pull them apart and put them and show you each individual one. All right? What's the matter? Oh my gosh. Seriously. Okay. So let's put these let's see. Let's turn these so that they look the same. Okay, now this is the big triangle is WXY, okay? The right angle is at X, okay? What was the right angle of the small triangle? What letter? Z, right? It's this one. So Z is the right angle. What side was the short leg? What letter does the short leg end at? Y. And the long leg at X. Okay? So right now we have Big Daddy triangle WXY is similar to triangle, baby triangle XZY. Okay? And then we have the mama bear triangle. Let me flip that. Okay? For the medium-sized triangle, the right angle is at what? Z. And if I go along the short leg, what do I end up at? X. And the long leg ends up at W. Okay? So I basically pull that apart, okay? And we can write a similarity statement. Let's start with the big triangle. That WXY is similar. And let's do the medium triangle. What goes with W? The medium triangle? Yeah, W. Okay, what side goes with X? Z, right? Because it's the right angle of the big triangle. It's the right angle of the medium one. And then what goes with Y? We went from W down the long leg and then up the short leg, so X. Does everybody see that? Because we had lots of different answers, so are we okay? Okay. And then the small triangle, okay, if we started at W, what is on the short triangle, what is that? On the little triangle? X. Okay, and then we travel down the long leg, and where we end up at the right angle, which is Z. And then we go down the short leg, which is Y. Okay? All right, so I would kind of think of like ought to go through and out loud say the path you're taking. Like to do this triangle, you went from across the long leg to the right angle and then down the short leg. And that way when you're talking about the other triangles, you can say that exact same thing. Okay, I need to go down the long leg, turn at the right angle and go the short leg. Or I gotta go across the hypotenuse and then up the short leg, or however you chose to write them. Okay, because remember, when we write similar triangles, you could start at any letter you want. You didn't have to start at W. You could have started at X, or you could have started at Y, right? You just have to be consistent with all three triangles. Okay? All right. So before we talk about corresponding parts, why don't you write the similarity statement for these triangles, and let's give them letters. This is A, B, C, and D. All right, you write the similarities. So we're going to be setting up proportions based on, corresponding parts, and that's going to help us solve for missing side lengths. For today, the other thing I want to do is talk about geometric mean. Okay, you've done arithmetic mean since probably like 4th grade. What's another word for mean? The average, right? So in an algebraic mean, you're just like, if I'm going to take the average of two numbers, what do? Right, add them together, divide by 2 if I'm adding two numbers, right? Well, in a geometric mean, okay, it's not progressing 1, 2, 3, 4. It's progressing more. The numbers get farther and farther apart the farther along we go. So instead of adding and dividing by 2, what we do is we take the two numbers, we multiply them, and take the square root. Okay? So succinctly, you take the square root of the product of two numbers. Okay? But that just means take the two numbers you're finding the geometric mean of, multiply them together, and take the square root. All right? So if I'm taking the geometric mean of 2 and 8, I'm going to multiply 2 times 8, which is 16, and then take the square root of that, which is 4. Okay? Let's do the next one. If I want the geometric mean of 10 and 30, what do I do there? Multiply them together, so 10 times 30 is 300. Take the square root. Now, do you guys remember how to simplify square roots? Because a simplified square root doesn't have any perfect squares underneath. So I break this down into 3 times 100, and I can break 100 down into 10 and 10. Do you remember? And if it has a partner, it gets to go outside the house, and if it's all by itself, it has to stay in the basement alone and play Nintendo. Right? Nintendo or Xbox. Okay, so the 10 comes outside the house, but the 3 has to stay inside because it does not have a partner. So that it's 10 square root of 3 is it simplified. Are we okay with that, or do you want to do one more on simplifying? Do simplify square root of 75. All right, so today what I really wanted you to get was writing similarity statements, putting the corresponding parts together, and calculating geometric mean. All right, do we feel like we got that? Okay.